Hi, good day. So we may say that this is the start of this course, Differential Calculus. How do we perform derivation or differentiating a function? So for example, we have this function with a curved graph. So let's say this function is represented by y is equal to f of x. Now, if you are to consider a second line, if we say a second line, that is a line that will intersect a given curve twice. So let's say these are the points. So a second line will intersect a curve twice. So let's say this is the first point, point P. The second point will be, let's say, P prime. So let's say the coordinate of this first point, at this from the origin, it is at a distance x, or it's abscissa x, and its ordinate, let's say the ordinate is y. If we say differential calculus or calculus, we are considering small change. So let's say there will be a change in x. Let's say this is the change in x, or delta x. And the change in y, let's say this is delta y. The change in x and y from point P to P prime. Considering this second line. So what is the coordinate of point P? We have the coordinate of point P is at point x, y. What will be the coordinate of P prime? So the coordinate of P prime, that will be x plus delta x, that will be its abscissa. We have, that is x plus delta x, that will be its abscissa. Then its ordinate, that will be y plus delta y. So we have, this is a y plus delta y. That will be the coordinate of P prime. So again, we have this curve. This is y is equal to f of x. So for example, we have y, there will be a change in x that will give us a corresponding change in y. Kung may pagbabago dun sa x, obviously, meron change dun sa y. So this is, we have delta y is equal to f. This is x plus, we have delta x. So we have this now delta y. Delta y is equal to f of x plus the delta x transpose minus y. Then we have delta y is now equal to f. This is x plus the delta x minus initial equivalent of y is the function of x, f of x. Now we are to divide all terms. Divide all terms with delta x. Okay, so we have delta y over delta x is equal to f of x plus delta x minus f of x all over delta x. So by definition, the derivative of y function for that is equal to the limit of the ratio delta y over delta x as delta x approaches to 0. That's how we apply limit into a derivation or differentiation. So we have, that is the same as y prime in some references. They're using y prime. That's the same as dy over dx, that is equal to the limit of the ratio, that is delta y over delta x as delta x approaches 0. And that is equal to, we have f of x plus the delta x minus f of x. This is all over delta x. That's how we apply derivative or differentiation. So from a second line, if we are to perform the first derivative on a given curve, that will be, or that will give us a tangent line. So this will be a tangent line. So take note, if we are to determine, for example, a second degree equation, if we are to determine the first derivative, that will give us the equation of its tangent line. So that, take note that dy over dx, that is the same as a rise over run. It represents slope. Okay, so that is how we apply limits into derivatives. Okay, so let's have an example. So differentiate the function y is equal to 3x squared minus 5x. So if we are just to follow the procedure, a while ago we have, we have y plus, this is delta y is equal to 3 times, there will be a corresponding change in x, that is x plus, or the delta x squared, minus 5 times x plus, or delta x. There will be corresponding small change, or delta y or delta x. So we have delta y is not equal to, this is the same as 3, let us just expand this one. That is the same as x squared, x delta x, plus x, or that is will be twice. We have twice of x delta x, then plus delta x, that will be delta x squared. Or less, that will be minus 5x, or less 5 delta x. Then we just transposing y, so that is minus y. So we have, this is now delta y is now equal to, we have 3x squared, then plus 6x delta x plus 3 delta x squared, then minus 5x minus 5 delta x minus, what is the initial equivalent of y? The initial equivalent of y is we have the initial function, that is, we have 3x squared minus 5x. Okay, so we further simplify. This is now delta y is now equal to 3x squared plus, we have the 6x delta x plus 3 delta x squared. Okay, we have minus 5x minus 5 delta x minus 3x squared plus, this negative times negative, plus 5x. So what will be, or what are the terms that will be remain? We have delta y, we have the remaining terms. We may remove 3x squared. What else? We have 5x. Okay, so the remaining terms will be having 6x delta x plus, we have 3 delta x squared, minus 5 delta x. Then, okay, divide all terms. We have to divide all terms with delta x. Okay, so what will be the equivalent of the ratio of delta y over delta x? This is now delta y over delta x. Okay, that will be equal to, we have 6x plus 3 delta x. This is the same as delta x squared divided by delta x minus 5. Now if we are to apply limit, we have dy over dx, or the same as y prime, is equal to the limit as delta x, delta y, of the ratio of delta y over delta x as delta x approaches 0. For the function, okay, so for the function 6x, or for this term 6x plus 3 delta x minus 5, all we have to do is substitute all values of delta x with 0. So that will be 6x plus, that is equal to 3 times 0 minus 5. So we'll be having equivalent of dy over dx, or the same as y prime. Our remaining term will be 6x minus 5. Right. So as you can see, this procedure is a bit long. We may consider this procedure of differentiation as a long procedure. Medyo mahaba siya. So that's why we have this formula that can be applied when it comes to the differentiation of algebraic functions. So for example, Okay, so how to determine the derivative of a constant? So for a constant, let's say the derivative of a constant with respect to x, let's say our variable of differentiation is x. Derivative of constant is always 0. Other than that, we may consider the derivative of a product. So for example, we have to determine the derivative with respect to x of the product of, let's say our first term is u, our second term is v. That will be equal to your first term, that is u, multiplied by the derivative of your second term, that is v, dv over dx, that is plus your second term, okay, multiplied by the derivative of your first term with respect to x. That will be the operation how to differentiate product of two terms. Then after the product, we have the quotient. I have to determine the derivative of the quotient with respect to x, for example, of u over b. So that will be, that is equal to your denominator, the derivative of your numerator, du over dx, minus your numerator multiplied by the derivative of your denominator all over your denominator squared. Okay. In some references, they're using this term for an easy way to memorize. That is u is your first term. So first term, derivative of your second term. Usually here in calculus, if we say derivative or first derivative, usually we are using prime. So your first term, dv over dx, derivative of the second term, plus the second term multiplied by the derivative of your first term. Okay, in some references, they are using this. First term times the derivative of your second term plus your second term times the derivative of your first term. When it comes to quotient, that is your denominator, derivative of your numerator minus your numerator multiplied by the derivative of your denominator divided by your denominator squared. So dn prime minus nd prime over d squared. So again, if I'm using prime, that means the first derivative. So that will be for the constant, product, then quotient. Then we have one more. Let's say we may consider this one. We have for the power, for the terms of, or the terms to the n power, let's say. Or some references, they're using the term power rule or the chain rule. So we have how to determine the derivative of u raised to n. Okay, with respect to x, for example. So it will be, all you have to do is, from your term, or from this function, bring down the exponent n, okay, your term, then your exponent less 1, okay, multiplied by the derivative of your base, the du over dx. You may apply this to any terms to the n power. Okay, so we may apply this common formula for differentiation to avoid that long procedure. Okay, so first example natin, we are using the previous example. We used the long method on this example. So let's see if we are to arrive with the same answer using this formula, or formula for shorter differentiation. So we have y is equal to 3x squared minus 5x. So let's determine the first derivative. We have this is equal to dy is equal to, you may directly isolate your constant, then apply the power rule, or the derivative of a function to the n power. That is your derivative of u raised to n is the same as bring down the exponent, okay, your base, your exponent minus 1 multiplied by the derivative of your base. So we have we have dy is equal to, we may isolate the constant, that is bring down the exponent to your base x, your exponent less 1. Then, multiplied by, what is our base? Our base is x. What is the derivative of x? That is dx. Then, minus, you may isolate the constant 5. What is the derivative of x? That is, we have dx. So, we are to simplify. This is now dy is equal to 3 times 2 is 6x. 2 minus 1 is raised to 1. But we may not place that one. This is understood. X raised to 1. Okay, dx minus 5 dx. Now, what we have to do is divide all terms with dx. So, we have the answer. This is the same as dy divided by dx is now equal to 6x less 5. So, the same answer from our previous procedure. So, this is more convenient compared to that procedure. Then, another example. Let's try a product. So you may expand that, or maybe let's try another one. Let's say we are required to determine the first derivative of the function y is equal to x minus 1 quantity squared divided by x plus 3. And we may consider our first term will be, this is x minus 1 squared. So let us determine the derivative of that term. So we have, this is u. How to determine the derivative of this one? So we may express this, you may use the power rule for this term. So all we have to do is bring down the exponent, that is 2, divided by your base is x minus 1. Your exponent less 1. Then determine the derivative of x minus 1. What is the derivative of x minus 1? So x minus 1, derivative of x is dx. Derivative of 1, that is a constant, that is 0. So we have the equivalent of du now is equal to simply twice of x minus 1 dx. That is for our first term. Then for our second term, let's say that is b. The derivative is equal to, the equivalent of b, our second term is x plus 3. We have the derivative of x plus 3 is simply, derivative of x is dx. Derivative of 3 is 0, that is constant. Now if we are to apply, we have the derivative of ub is the same as your first term u, derivative of the second term db, plus the second term b, derivative of the first term. So that is u db plus bd u. So we have derivative of y, this is now dy is now equal to, what is our first term? U. Our first term is x minus 1 squared. Derivative, that is db. Derivative of the second term, that is, we have dx. Then plus, that is plus. Your second term, that is our second term, or that is b, that is, we have x plus 3. Then derivative of our first term, that is the same as, we have twice of, the derivative of the first term, this is twice of x minus 1 dx. Then again, dividing all terms with dx. Okay, so we will be having, this is divided by dx. So we have y prime is equal to dy over dx. Okay, that will be the equivalent on the right side. That is the same as x minus 1 squared, then plus, okay, we may simplify that one as x plus 3. Okay, we are to distribute this one. This is 2x minus 1. So this is multiplied by 2x times, okay, 2 times x, then minus 2. Then we may simplify, we may further simplify. So we have y prime is now equal to, this is x squared minus 2x plus 1, then plus, okay, this is x times 2x, we have 2x squared minus 2x, that is x times negative 2, plus 6x minus 6. Then, okay, we may simplify, further simplify. We have y prime, okay, we have x squared, this is 3x squared, negative 2x, 6x, that will be plus 2x. Then, okay, the last, we have 1, okay, minus 6, that is negative 5. So this will be y prime is equal to 3x squared plus 2x minus 5. Or we may, okay, can we check? And so set the derivative of a quotient. So for example, we have y is equal to 5x squared minus 4, that is all over 2x minus 1. So our numerator, that is u, our numerator is equal to, we have 5x squared minus 4. What will be the derivative of your numerator? Okay, our du. So that is the same as, okay, we may apply power rule, bring down the exponent. That is 5 times 2x, the exponent minus 1, multiplied by the derivative of your base x, that is the same as dx. Derivative of 4, which is a constant, is 0. So this is the same as du equal to 10x. Alright, 10x dx. So never mind that the 4 that is a constant. Then for our denominator is equal to 2x minus 1. So this is your first derivative, db will be equal to twice derivative of x is dx. So negative 1, derivative of constant is 0. Now if we are to apply, the derivative of a quotient is equal to your denominator derivative of your numerator minus numerator derivative of the denominator divided by the denominator squared. Okay, let us just apply. So we have, this is y, or this is the same as dy is now equal to, okay, that is b. What is our denominator? That is, we have 2x minus 1. du, what is the derivative of your numerator? That is, we have 10x dx. Okay, minus your numerator, that is, we have 5x squared minus 4. Derivative of the denominator is twice of dx. Okay, all over, we have your denominator, that is, we have 2x minus 1 squared. Okay, then we simplify. So, we may divide both sides of the equation by dx. As you can see here, we can factor out dx. So we have dy over dx, or it is the same as y prime is equal to, we have 2x times 10x is 20x squared minus 10x. Okay. Then we have less 5x squared times 2 is 10x squared. Okay, negative. Then negative times negative is positive times 2, that is plus, okay, plus 8. This is all over, we have the 2x minus 1 squared. So maybe we can further simplify. This is now a y prime is now equal to 10x squared minus 10x squared is 10x squared. Then minus 10x plus 8. This is all over, we have 2x minus 1 squared. Maybe we can expand the denominator, but I think we can no longer simplify. So this will be a y prime, the derivative of this function y is equal to 5x squared minus 4 all over 2x minus. Alright, so how about this one? We have y is equal to 5 all over x raised to 6. So we may apply two rules here. We may do two rules. We have the quotient rule and the power rule or the chain rule. So for example, if you are to use the quotient rule, we have your numerator is 5, derivative of a constant is obviously 0. Then we have your denominator is x raised to 6. Then applying power rule, dv, all we have to do is bring down the exponent 6, your base x raised to 6 minus 1. The derivative of your base is dx. So we have the derivative of your denominator, dv, is the same as 6x raised to 5 dx. Then we may apply the derivative of a quotient is equal to, that is, your denominator, derivative of your numerator minus your numerator, derivative of the denominator divided by the denominator squared. So we have, that is, we have y or dy is equal to v. That is your numerator, that is x raised to 6. du, that is 0. Okay, minus your numerator is 5. Then derivative of your denominator, that is multiplied by 6x raised to 5 dx. Then this is divided by your denominator. We have 6. We have, that is x raised to 6 quantity squared. Alright, if you are to simplify this one, so this is obviously 0. This is dy. We may divide dx both sides over dx. Remaining terms will be, that is negative 5. Negative 5 times 6x raised to 5 is negative 30x raised to 5. This is divided by x raised to 6 raised to 2 is x raised to 12. Then we have dy over dx is the same as y prime, so equal to, this is negative 30. We may cancel this one, x raised to 5 and x raised to 12. Remaining will be 7. So this is the same as negative 30 over x raised to 7. That is applying the rule of a quotient. What about, we can still apply power rule or the chain rule. We may do that. So we have y is equal to, that is the same as 5. How to bring x raised to 6 to the numerator? What we have to do is, by x raised to negative 6. Then we may apply the power rule or the chain rule. So we have y is equal to 5. You may isolate constant already. So all you have to do is bring down the exponent, which is this time negative 6. Your base, your base x, this is negative 6 minus 1. Supposedly we have this as dy, then derivative of your base x is dx. So dy over dx, or this is the same as the y prime, is 5 times negative 6 is equal to negative 30 x raised to negative 7. So we have now y prime is equal to negative 30 divided by x raised to 7. So we are left with the same answer. So you may choose what procedure or what formula can be more convenient compared to the other. So tingnan niyo lang kung ano yung mas madali or mas maigsi yung solution. So you may do an experiment kung ano yung mas madali. It is for this example. Let's try another one. Okay, so let's say we have y is equal to the square root of x minus 1. So we are required to determine the first derivative. We may apply the chain rule or the power rule. So considering your sa power rule, the derivative of u raised to n is equal to n u raised to n minus 1 du. So for example dito, your u is equal to x minus 1. Derivative of that term is equal to, obviously, derivative of x is dx, negative 1 is 0. So you may convert this one into an exponent, obviously. So we have, this is y is equal to, it is the same as x minus 1. If we say square root, that is the same as raised to 1/2. Then apply the power rule. So let's say this is now dy is not equal to, applying chain rule or power rule, bring down the exponent. This is 1/2 multiplied by x minus 1. The exponent less 1. Derivative of your base, what is our derivative of the base? Dx divided by dx. So again we have dy is equal to dy divided by dx is not equal to, this is 1/2 of x minus 1. 1/2 minus 1 is negative 1/2. To simplify, this is the same as dy over dx is y prime is not equal to, this is the same as 1 divided by 2 multiplied by x minus 1. Okay, to make the exponent positive, bring it down. Okay, so that is the same as y prime is not equal to 1 over twice of x minus 1. The quantity x minus 1 raised to 1.